vertical asymptotes. For simplified rational functions, r of x equals p of x divided by q of x, if the limit as x tends to x1 of q of x equals 0, then the line x equals x1 is a vertical asymptote. Now this is kind of a strange way to write it. Pause the video and see if you can tell me why it's a bit weird to write it like this. Well, the answer is because r of x is a rational function, and so q of x is a polynomial. And since q of x is a polynomial, if the limit as x tends towards x1 of q of x equals 0, this is just equivalent to saying that q of x1 equals 0. So maybe a bit over the top to start going on about limits, but I don't know. It's the same thing anyway. It doesn't really matter. Maybe the dum-dum who wrote this was trying to sound smart. Okay, now you might be sitting there going, well, what about p of x? So if the limit as x tends towards x1 of p of x also equals 0, so that's true if and only if p of x1 equals 0, then well, I mean, maybe this thing, maybe the function is not defined at, so maybe r of x1 is not defined, but if p of x is also getting close to 0 as q of x is getting close to 0, maybe the whole thing is getting close to 1 or 2 or something. So it might not necessarily have to take this shape where we're going off to infinity on one side and negative infinity on the other. So, well, the answer to that question is because they are simplified. Because they are simplified rational functions. If q of x1 equals 0, then we actually cannot have p of x1 equals 0. Otherwise, we would have r of x is equal to x minus x1 times p1 of x divided by x minus x1 of q1, so times q1 of x. And so then it wouldn't be a simplified rational function because we could cancel that factor and have two new polynomials, p1 and q1. Therefore, since, well, if q of x1 equals 0, we're guaranteed for simplified rational functions. So q of x1 equals 0 implies p of x1 does not equal 0. So that means we're guaranteed to have this vertical asymptote shape. Alright, so that's it. To find the vertical asymptotes for a simplified rational function, all you gotta do is just find the values where your q of x is equal to 0. And in this case, one of them would be 4, and the other one would be negative 1. So those are our two vertical asymptotes for this function. For simplified rational functions, it also doesn't matter about the degree of p of x or the degree of q of x. They can have any degrees, but as long as q of x1 equals 0, and it's a simplified rational function, then there is, well, you're guaranteed to have a vertical asymptote at that point. For example, you could go to Desmos and you could graph y equals, I don't know, x plus 2 divided by x minus 3 times x minus 4 times x minus 5, and you can do as many of them as you like, and you would see that there are asymptotes at 3, 4, 5, all the way up to n. That was just worth noting because when we talk about horizontal asymptotes next, the degrees of the polynomials are kind of important there. And same for oblique asymptotes.